Hello guys, welcome to Tech Detonator Show and the third episode of Tech Podcast series. Today we are going to take a sneak peek into how the Canadian institutions teach and design their curriculum for the students. Specifically, I've taken a case study of University of Manitoba, which is situated in Winnipeg, Manitoba, and it is one of the top ranking schools in Canada. I've invited a guest, Professor Robert Guderian, who has experience of teaching since 8 to 9 years, and he is specifically focused in how to make a bridge between academic experience of students and the real life industrial experience. So today we are going to talk to him and research about how they design their curriculum and stay up to date with the current changing world, specifically when these challenging situations come after COVID, when the AI new tools have been researched and developed. How did you come across the field of computer science as a child? Like, how was your interest cultivated?
Oh, that's actually an interesting story. This is a million years ago. So I got my first computer when I was going into grade 10. So between grade 9 and grade 10, which was 1999. And it was the first household computer had. So it was like in the dining room because there was no computer rooms back then. And I was messing around with it. And my friends had computers and I was always like kind of watching what they were doing. I was always very interested. And there was a option in my high school to take a mathematics and computer science, not degree, what do they call that in high school again? I'm so indoctrinated. A diploma program. And I said, sure, I like this stuff, so why not? And my friend was also going into it, so I'll be able to go with my best friend. We'll be in this class together. It's going to be great. My best friend had computers since he was born. His dad was always interested in computing, and they always had like some kind of, back then, actually quite basic computers that were just booting off ROMs. And so my friend was in there and he knew everything about computers. And I had literally just gotten one. So I knew nothing. By the end of the year, I was the third highest mark in the class. It was the person who had taken programming lessons outside of school, the person who cheated off that person, and then me. And my friend barely passed the course. So it was really fascinating to see go in, and the idea of having this previous knowledge didn't really come into the equation. It was all about how do you actually interact with this material. And that was the first time I've actually even thought about computer science education, and also my first dive into writing a program.
Great. That sounds like a really good story. How so when you were growing up, how was your studies? Was it difficult compared to current times, or was it really easy or lengthy?
That's interesting. I feel like it's been somewhat constant. It's always hard. Like, what we do is hard, and that's something we actually have to remind ourselves, especially if coming to the end of our degree, we can look back and at 1010 or like our intro computer science class and be like, well, why are they doing so badly? This is basic material, but the first time you get into it, you're learning if while for, and somehow that's very hard. And the idea of like when am I making a decision? When am I repeating making that decision? And how do I set this up? It's just a constant difficulty. So I don't know if it's, you're like thinking like to, I guess, kind of CS1, CS2, like I'd say they're about the same difficulty.
Okay, so around it's about 20 years or 30 years you have complete around 20 years, right? Around you completed your
I don't like to say it
uh
out loud, but yeah, I've been
yeah.
programming for 23 years. Yeah.
I don't see it that way, but you have been you have completed around your education ago 20 years ago, right? So after that, how many like how does the computer world shape, or like how did the education system around the computers change? Like it was not that important around 20 years ago, but now it is like clearly very important to most of the students. Around 70% students choose computer science stream or some way or other.
Yeah. Well, it's I guess computer science has always been somewhat popular. I think people are a little bit more skeptical of it. When I joined university, I believe it was 2003, and there was the dot-com boom and dot-com bust in 2000. So there was worries that all these jobs would be going away. All of these jobs would be going to offshore countries where labor is cheaper. There was concerns that there was just like, oh, this well has gone dry. There's nothing here. So there was actually a kind of a depression in computer science uptake then, but 10 years before that, they're actually booming. So it's always cyclic. But I think people didn't have a good sense of why you'd go into like computer programming and computer science in the 2000s, because it was still very much, there was a household computer and it did some very practical tasks. It's very good at doing these spreadsheet things, but kids like me was like, I can play video games on this thing. And that was why me and many people like me got into computer science. Was like, I play video games on this thing. What else can this thing do? And yes, most of like the what else can this thing do is where lots of the interesting work is, and video games are cool, but there's so much more it can do, and people then didn't see it. These days, computers are, almost everyone has one. There's a computer in your pocket. Prove me wrong. And the idea of what computation is has changed, though. People are getting further away from understanding what these things do, and the idea of programming as a challenge has changed, because people. This sounds odd, or worse, are using computers now than 10 years ago.
Okay. Yeah, like I have come across many people, they think that the back end coding is very simple and they think that everybody can do it. But so they start to choose the streams, and I have come across around 10 to 15 people who have started choosing the stream, but when they proceed into, or 1 to 2 years into the computer stream, they tend to think that, oh man, this field is tough, and they start to diverge from the field and start to look for escaping routes from this stream. So what is your advice, like how should the kids prepare from the, like around 7th or 8th grade, they start to get the understanding like what they want to pursue in the future? So what should be the preparation for the kids coming in the future?
That's interesting. I think programming earlier is going to help, obviously. But like that feeding into like the systems and like back end and like what is, like you said, quite hard work. There is actually some neat stuff we can do. So I've never actually played with Scratch myself, and that's like very introductory programming language where you can drag and drop these tiles, and then that'll create procedure. What I didn't realize, and I found this out last week, is that Scratch out of the box is parallelized, or at least concurrent. So every single sprite on the screen actually has its own thread. They will not call it that, but it is their own threads. And I'm hoping that these kids that are using Scratch will be able to, without even realizing it, be able to do this concurrent programming, because they just have these concurrent objects moving around. It's like, well, once the cat bumps into the apple, they'll notice each other, and the apple will go crunch and the cat will go yum, yum, yum. That's a program I wrote last week, but it was a concurrent program in Scratch. So I think they have a big advantage there, because when we introduce concurrency, that's when everything goes off the rails for a lot of students, because the mental shift from writing a program that runs from top to bottom, and now I have multiple programs that are maybe not running top to bottom. Like that's a huge conceptual shift.
So that is the concept of distributed computing, right? If I guess it right.
Yeah, distributed, and you'll find it in operating systems too. At the university I work at, the University of Manitoba, which you should attend. It's amazing. That's also where we have our concurrency part. So that's where the students are first exposed to threads. We are trying to push the concept of threads down to second year, and hopefully that'll happen soonish, and that's soonish in university time, which is kind of 2 to 5 years, because it doesn't really belong in operating systems. It's put into operating systems because the operating system is what allows you to do concurrency, but the actual concurrent the idea of concurrent programming and having cooperative objects is not an operating systems topic. So it's a funny place to have it. It makes sense, but it also doesn't.
Oh,
But
great.
yeah, so distributed and operating systems both have it.
So looking at your experience in academia and as well as official in the corporate world, I've seen that you have worked as system administrator in past, and then you started working at University of Manitoba. So what do you think? How does the educational institution world and the corporate world intersect each other? Where does it intersect each other? Like how much that is what is taught in the universities is real as compared to what is experiencing in the corporate world?
That's an excellent question. That is actually frequently an interview question for people coming into the university, because we serve a kind of many masters where we have this idea of like we're a higher learning place of higher learning. So like our graduates should be interested in going to a graduate program. So we're doing their master's, doing their PhD, and we need to be able to make sure that stream is there. But lots of our graduates will also go to industry, and we want them to be prepared. But at the same time, it's not a technical college. So what should the balance be between getting people ready for postgraduate work and for industry work? And there's no simple answer to that. And you can ask five academics and you'll get 16 answers. So it's a real hard problem. We try to teach it as like these are the fundamental tools that you'll need, but we also don't try to teach you a single tool. So we're not trying to make C# programmers. We're not trying to make Java programmers. We teach Java, but that's just a means to an end.
So you are trying to teach object-oriented programming in shape of if the language is being taught in the class, it means that you have to learn the concept, not the exact language, but the concept is being taught to prepare the base for students when they go out in the corporate world.
Yeah, that's right. And I get to teach distributed systems, and it's a lot of people's first time seeing Python, and I don't teach them that in the class. So I have a little primer saying, okay, you should be able to pick this up. But here's 30 minutes of me talking through the syntax because all the concepts are the same. So those fundamentals that I just mentioned, all those are the same. It's if, for, while. But what does it look like in Python? It's like, oh, hey, like brackets went away. It's spaceless now. Isn't that crazy? Okay, let's go. And then by and large, students pick it up and they are fairly good Python programmers after the 3-4 months of the course.
Yeah, definitely. Python is like, as Python was introduced later than Java, so it has many less restrictions, but it is also more flexible than other languages especially for machine learning and stuff. Like Python is really good for getting the analysis and the graph records and stuff, or the training the ML models, right?
Yeah, it's a bit of a disaster to teach Python first to people because they're used to like, I just need a variable. I can pull it out of the air and it'll be any type I want it to be. And then all of a sudden we say, it's like, actually it's slow because we do that. And then we give them a typed language and they're like, why do I have these shackles on? There's nothing worse than this. So yeah, it is nice to teach the typed language first and then say, oh, wait, by the way, we can also do this very loose thing, which causes some very interesting bugs.
Yeah, so some people perceive it like, now I'm free, I can do anything in Python.
I got to pass in they'll have a function. It's like, I got to pass in an int or a string. I don't know. It'll maybe figure it out. Then it doesn't. And then they're at their kind of abilities end. And that's.
Yeah, like that's where the real computer science starts, right? If your bases are clear, then you can maybe find out why your program is not working. Even in Python, definitely it does figure out it on itself for the basic things, but when you go into deeper, when the programming is real intense and it's complicated, then you need to mention a few things which to computer system.
Yeah, the software engineering skills come into play where you're actually having to layer your program, create a structure, and then you're actually creating something instead of just hacking. And Python's really good at letting you be a hacker. It's actually, once you build a real program, it becomes just as hard as doing Java, C#, whatever you want to have, because you have to kind of do it properly.
S- Uh, so, what do you think should be the basic skills if a student is getting out into the corporate world, or it's when they are learning in the bachelor's or diploma? What should be the most important skills that they should develop apart from programming?
The hardest thing is being able to talk to humans, and that's something that we're not actually very good at teaching here, and
Yeah.
it's very hard to teach too. I have the pleasure of teaching software engineering this summer, and I kind of get to be reminded of that, where people hate these project courses because I have to work with these other people. It's like, yes, but there is some things that I'm not grading you on that are going to be very important for you later. Like, how do other people work? And people are finding out. They come to me. It's like, somebody actually used the line, should I be lowering my expectations with this group? I was like, it was the first time that they realized that they're actually really good at what they do, and uh, on average, our students are average. So he had some average, not even bad students in his group, and he was kind of shocked and like, well, how do I work with this? And like, well, my friends, you're going to have lots of really good answers to questions in interviews. All the questions like, tell me about a time that you had problems with a group member. It's like, well, let me tell you, you're going to have all of these great experiences. So,
Yeah, I think that should be a that like is a natural skill, being how to act with other humans and how to coordinate with the other people is, I guess, the toughest skill.
no,
You
it's
have to
very
put
hard.
your ego aside, and
Yeah.
that is the toughest thing for people to do and care for others. Yeah.
Yeah.
So
I guess technical skills were probably what you're asking me about, but I did not
yeah,
go there. The
definitely.
technical skills I think are interesting. It is still about like the one foot in front of each other. So it goes all the way back to CS1, where it's, say you're looking at a problem and you have these tools. How do you solve this? But the problems get bigger and bigger and bigger and bigger. And and it's interesting to actually take that step back and say, wait, I learned these skills 5 years ago, but now I have more tools, I have more ideas, I know some of these algorithms, I know I can fit them in. And sometimes now it's not, we're just thinking about an if statement to try to make a menu application work. Now you're thinking about, well, I know that this algorithm can fit into this problem, and being able to match those things. Because I think everyone is going to go out into every job I've started, I've run into the knapsack problem almost in the first year or so of working there, where they're like, well, we have this, and how many of these can we fit into here? And I was like, that's a hard problem, my friend. And actually knowing that and being able to recognize a problem and recognize that there is no easy solution to this problem is a huge part of it. So being able to map those, like the tools you have, to these problems is the hard part, and what you
Okay.
should learn.
Okay, that is a great deal. Please, guys, listen to this very carefully. So, have you noticed any challenges for the current students when they are in the third or fourth year, or they are really into their advanced education? What is the main challenge that they face, and what is the issue how can they solve that issue?
Yeah. So I teach a bunch of third-year classes. So what I see is students coming in and they've found it easy so far. And that's part of a problem with our program, where at our university, to get into physics, you need to have high school physics. To get into mathematics, you need high school mathematics. To get into computer science, you need a pulse. So our first year of computer science is high school, and our second year is first year and a bit of second year, and our third year is third year. So there's this big gap where all of a sudden it's like, hey, we've taught you all these basics, we're going to put them together now. So this goes back to the previous question, is like, how do you do this? I'm going to call it big brain thinking, because that's pretty much what it is, where it's like you have these bigger tools and you have these big ideas floating around. How do you put these big ideas together? But we're doing that in C programming. So you have big ideas, big algorithms, and really picky languages and really picky ways that you need to actually implement it. And That's really hard. Um, actually was at a conference last week or the week before, and I drew myself a Venn diagram of like, why is computer science hard? And I was looking around the room and we was talking about academic integrity, and lots of people are talking about like ChatGPT is going to end the world because they are not in computer science and just discovered that artificial intelligence has been moving along. And I'm thinking like, well, this is a solved problem for me. Like I know, but okay, like why are they scared and why is it different for me? And I was trying to put this together, and I saw that we have this intersection of a few different things. And third year is when you start to really see this, where you have to have this creative thing where you're like writing essays, but that essay is in code, and you have all these ideas. You need to be able to express them. But it's also the mathematical part of it where you actually need to write it down. So you actually have this hard syntax that is all these tools that I was talking about. And there's also the engineering part where it's not just mechanical. I can't just give you a problem and just have you mechanically type it out, because it's like, it's not me asking you to do a differential, basically. Like a differential, there's one way to do it. This is the path. Now it's like, there's kind of an engineering part of it where we have this essay that's very picky and we have to have this like really solid thing, but we need to put together with this, like these engineering tools and have shape to our program. And okay, all of these things are actually really hard, and we're right smack dab in the middle. And in third year, you're kind of let off the leash, and we're like, here's a big enough problem that there's not just one mechanical solution. You have to understand these big things, and it's going to be picky. And people find themselves maybe not fitting all of those parts of the Venn diagram as well as they'd maybe thought they did, or maybe they just never picked up those skills, and it's a big gap that they have in their knowledge.
Yeah, that sounds about very accurate from my experience as well as many other people I have come across. Um, so also there are many students who start working early with their education as well. So how should they create a balanced curriculum such that they don't face problems scoring the good grades, as well as I think the work is mandatory, they have to do it, that's why they do it. So what should be the real striking balance that works perfectly?
I'm gonna make some enemies. Here we go.
Uh,
So in second year, what happens if you get a C? Well, you're allowed to go on, but if you get a C in a course in second year and you go into third year, there's actually a gap, right? Where C's get degrees. Everyone loves that saying. It's true, but there's an expectation that you actually knew that stuff from the previous year. So if you get lower marks, it's really important that you take a step back and reflect. It's like, okay, what did I not pick up here? And you always have a few weeks between courses. Sit down and actually review that material. And it's very hard to be honest with yourself, because it's very easy to say, it's like, well, I got it, I just didn't test well. I've said that. I know there's probably some people listening that have said that, but being honest with yourself, it's like, okay, obviously I didn't get it to the expectation level of what was there. And going back and looking at the material and saying, okay, I need to brush up on this stuff in case I need to use it later. So I think that, like, I teach operating systems. It's a very hard course, and it's in C. And some people will have not even seen C before, but that's not a problem. It's the idea of, like, have you actually stopped to consider what a programming language is, and can you apply those things you learned there to this new tool that might be C programming, but it's just another tool. So I guess it's somewhere between, like, reviewing that material, whether you did good or bad, if I'm being honest, and taking that step back and saying, okay, what was I supposed to take away from this? So the idea of retrospection, which sounds really like educational and silly. It's like, oh, I'm gonna do a retrospective on this and see what I could do. What did I do well? What could I do better? And how can I fix it? Like, sure, that sounds really hokey, but it actually does work. And that's something that I've been adding to my workflow at work too, saying, like, okay, well, that course didn't go well. Can I improve it? And taking that, hindsight to see if you can improve that and improve yourself.
Great. That sounds like a really good advice. Moreover, like, there is also issue there is also a debate since years that how the theoretical and practical knowledge go together hand in hand. Sometimes it people complain that there is more theoretical in this university and there is more practical in this college or university, and they start debating on the streets. I have seen that many people doing that. So what is the real sweet spot, like how much of a theoretical and practical knowledge is perfect for you to be successful in your career?
Uh, I'm on the much more on the technical side of the kind of spectrum of computer science. The way I see computer science is it's always both, right? It's this theory and you can do all this math and it's cool, but you also have to be able to do it and show it working. And the mixture of those two is what gets me really excited about this field. If you don't believe me, come to my distributed class one day and you'll see me just be excited every day about this theory and we can go do it. Let's go do it. And this is fun. So it does have to be a mix of both, but the doing it is generally just work. And usually you can write it down and it'll just take some time using your software engineering skills to like shape this program. I actually think the theory is more important than a lot of people give it credit because, right. And it depends what you want to do with your life too. So if you want to be a computer programmer, I encourage you to go to a technical college. If you're in Winnipeg, go to Red River College. Like they will teach you a programming language. And if that's what you want, I encourage you to do that. But to be in computer science, you really need to be able to see both and being able to see the theoretical side, know enough theory to, again, recognize something like the knapsack problem, be like, this is real bad. And then reflect. Or if you actually have some kind of optimization problem that you're working on at work, that's something that I don't believe Red River College would teach you, but at a university you'd have had seen some kind of like, hey, some kind of problem where it's like, okay, well, this is an indexing problem. I can start to use these tools. I need to shape this. Well, maybe I can put it into a tree and then start using these really high level theoretical things and drawing boxes and lines, because computer science is mostly drawing boxes and lines, and then be able to create that solution and then code that solution. And so it's not just coding. You have to be able to think of a novel way of solving a problem and then be able to solve it.
Yeah, that sounds about right. What I was thinking, what I was assuming, it's around the same answer. And so with the rapid advancements right now going on in the corporate world, like the ChatGPT 4 came out just about right now, and there are many advancements that are still predicted that will come faster than predicted, because the ChatGPT is around, I guess, 5 to 7 years earlier than what it was assumed to be here. So many practical implications of ChatGPT will also be here as soon as possible. Around, I guess, till 2030, there will be many things that will surprise everybody, every civilian. So what is the real thing that people should focus on to maintain their careers? Because right now many people are already afraid of losing their careers to these things. And so what is a good thing to do?
Well, in industry, most of us are software engineers. There are some people that do the theoretical part, and that's really cool. But by and large, we're doing software engineering. And I've come to create the line, and I believe this is my quote, and I have not stolen this, is that us as humans, we can't understand other humans' requirements. A computer doesn't have a chance. So it goes back to the first question you asked me was like, what should you take away from university? And I said, it's the people skills. And those people skills is what is going to make you important in a workplace, that you can actually go talk to someone, understand their problem, be able to form that into a project, and then use your software engineering skills, which is probably drawing boxes and lines, and then explaining that to a developer, and that developer might turn into something AI system, and then you'd be an AI programmer. But you'd still be that point of translation of this big problem that needs to be solved, and then turning it into requirements, and then pushing that into some kind of actual code.
Okay. So that seems, suddenly it seems easy. How
Don't be
you
a junior
explain it?
developer is what I just answered.
It suddenly it seems easy. The way you you made it seem easy, I guess. But what is the with this challenges? What is the uh, I can't find the word. Like it's really tough for people to focus on their careers and not get lost in the personal developments. Uh, so what is the one thing they should try to avoid while they're studying studying this in this last part of their careers, or they're doing masters or PhD?
Just they avoid having a social life is going to kill your academic life. No, it's I don't know. It's kind of an eyes on the prize, and I don't know if there's one answer to that. I know that when I was doing my master's program, I was getting distracted, and thinking about I started, I guess, to take a few steps back. I was taking my course, and I found out that I could do some sessional teaching. I'm like, oh, neat! I can teach a class as a grad student. And now, at that time, that was actually a complete waste of my time. It turned out for me, but it was just something that I wanted to do as an adventure. I wanted to say that I taught a university class, so I got to teach comp. It was actually called Comp 1020, which is our second course in our degree, and I got to teach it as a summer evening class, and it was just a completely lovely experience. So I ended up teaching more and more, and it was a distraction from what I was trying to achieve. But sometimes the distractions are, hey, maybe this is what I'm actually interested in. And I was lucky enough to have my life coalesce that I have a computer science background, and all of these courses I taught all turned into this job that I have now, which is teaching full time at a university, which is awesome, by the way. It's a great job. But I don't know, like you have to let yourself be distracted a bit and learn the things you want to learn. And I don't think that's a bad thing, but you still also have to focus enough on your goals that you actually do finish. So I don't know if that's a good answer, but
I think that's a very good answer, because I find that more than personal relationships, the money lures you away from your personal goals that you want to achieve. I've seen many people diverging from studies and keep earning, then at the end they have to do the course again.
Yeah.
And they find that they failed the course or something like that. So that is a general experience I have seen many people come across.
Yeah, those are really hard emails to get on my side, where somebody's like, I didn't get this done because I work full time, and also this is happening in my life, and this is happening in my life, and like there's nothing actionable for me there, except like I feel for you, and that's one of the reasons I usually have my assignments open for like a super long time. So if you are busy, the idea of like time management becomes huge, and being really intentional about time management is hard.
Yeah, that's true. It is, I guess, one of the most important skills in your life. Time management is like really important when you are growing old. When you are still small, around, I guess, till 25 years of time, you might not realize it, but suddenly after 30, people start realizing that, okay, time management, it's really getting difficult now.
Yeah.
So,
and yeah, good. And it's funny because you do have to carve out time for your interests,
family, interests, hobby.
And yeah, like, and trying to like work that into a schedule and then sticking to it. It's wild.
Yeah, it's wild. So when we talk about computer science, it's not only technology that will empower the computers, but many times it is used in other disciplines beyond computer science. So how do you think the mindset of a computer scientist or a software engineer works in other disciplines beyond computer science?
Oh, so like people that are kind of like interested in like, I guess it's a domain knowledge from somewhere else and then coming into computer science. Those people are really cool.
And also those people who go out from computer science to work in other fields, like for both of them.
Yeah, that's right. No, it's I think honestly that's where all the cool stuff is like the cross-disciplinary way of thinking. And I love spotting them in my class. Like I can usually look at the student numbers and I'll sort them and like, okay, who are the old folks here? And I'll often go out of my way to like say, hey, like your student, like I had a student that had a student number within about 1,000 of mine. That means we signed up for university on the same week. And they were in my class and I was like, what brings you back? And they were like, well, I was out doing this. And I ended up doing, it was in agriculture. And I ended up doing lots of spreadsheets. And then I was automating those spreadsheets. And then I was starting to make a program. And I was like, hey, there's something to this. And they had this really big determination because they knew that there was this niche that was available to them, then not to almost anyone else on earth, because they have this deep knowledge of agriculture. Now they're tying in this computer science part, and so they can dream of algorithms and build software, understanding the domain of, in this case, agriculture. But I also have people that have chemistry backgrounds and biotechnician stuff backgrounds and like all these really cool people. And I was like, okay, well, you've really got something here. Like, you called me a unicorn, right? Like, there's no one else like you. Put them in the right position, like a company will seek them out because they're so impossible to find. Flip that script. My first job out of my graduate studies was in cybersecurity. And I had a passing knowledge of cybersecurity, like in my systems administration days. That was kind of between my undergrad and graduate studies. I was working on Hollywood films. And guess what? People want Hollywood films. So part of that was keeping other people out of the network. I learned enough to like make sure that we are okay. But like looking at cybersecurity in a larger context was a new step for me. So I wasn't a professional. And actually had a conversation with someone from our managed security services area. And they told, I said, it's like, yeah, it has to be this way. And it's like, well, you're not a security professional. I'm going to ask one of my guys. And I'm like, okay. Person, of course, agreed with me. And then I thought to myself, it's like, you're right. I'm a professional. I have this background. I'm like a master's of computer science. I'm not no one. I'm good at least one thing. But that thing is huge. So I actually went and I got a certificate. I have CISSP, Certified Information Security. Wow, I don't even know the acronym. Professional, and it's actually a fairly hard certificate to get. And that was just to say, be at work and be like, no, I am a professional in this, but I can apply it to this, and all of a sudden I have these two things, and I can start making those links. Which actually goes back to me saying what's hard about third year is making those links. So that is the idea of like, hey, we have these bigger tools. Let's take this whole computer science thing as one tool and start applying that to something else. But you have to be professional at that too to be able to make those links.
That's very interesting to know, actually. So
my very shady background in cybersecurity.
yeah, also apart from the background, I mean, that's really impressive knowledge that you just imparted, like what people should focus on right now.
Yeah.
So how do you assess the students' learning in this generation around 2020 to 2025? How do you assess your students' learning and progress in computer science? I mean, are there any innovative assessments in the university, or are there any plans for new assessments to bring in?
Yeah, that's a very hot topic. So obviously we have AI that can do fairly good programs. Even in my operating systems class, which is INSEE and hard and picky and stuff, I managed to get solutions for all three of my assignments out of ChatGPT in a workable format in 10 minutes. And I was like, okay, that means my students can do this too. But what does that make us as, computer science students and people who are using this tool? And it makes us debuggers, which is a really unusual thing. Like, this thing's making software for us. Does that software work? Can you read that software? So we still need these basic tools of being able to read software, and reading somebody else's code is so much worse than writing your own. there's a quote. I think it's probably from Leslie Lamport, because all the good quotes are from there, and it's uh, writing code is twice as hard as reading code is twice as hard as writing code. So if you're writing at the peak of your limit, there's actually no way that you can actually read your own code.
That's a great insight.
Oh, it's so good. Leslie Lamport has amazing quotes. And so now we have this machine that's putting out code that it thinks is going to be palatable to us. And we have to remember that software is for the human, not for computers. Like, source code is not for computers. And like, when I say that in class, people stare at me like I'm like some ape. Like, no. Like, we compile this and then it turns into machine language. Like, we're not writing ones and zeros. That's because that's for computers. Like, these variable names, these are for us. These function names, these are for us. So yeah, debugging something out of ChatGPT is like cool. And that's something that people are going to be using in industry for sure. But from like a university professor standpoint, where I want you to learn this, I have to say, it's like, well, you have to have your fundamentals, and then you can start seeing this software and knowing what it does. And yeah, it's going to be a really neat tool. I'm excited. What's going to happen in class, so you talked about kind of teaching and evaluation, is that it's going to be more discussion based and more like talking to people, and potentially one of those people is ChatGPT people, loosely stated, and creating these solutions. So we have a problem, we have solutions. So this is a tool, and would be idiots to ignore it. So how do we put this into our development pipeline of either, whether it be for an assignment or be for some kind of project that we have in industry?
Okay, that is nice. But like, as ChatGPT can teach students whose basics are clear, so do you think that the physical universities do need to exist in future or not?
I think that's interesting. I like that.
For this specific computer science field, I mean, definitely for chemistry labs or something,
Yeah,
people need
the wet
universities.
labs are hard to replace the ChatGPT.
Yeah, they are not replaceable. But the computer science world, I think it's pretty easy to replace, but at the same time, it is very hard to replace and trust the system to create good programmers as it did in the past 2 decades.
Yeah. Well, yeah, I guess the death of computer science has been slated a number of times. So when like we moved from typing like legitimate ones and zeros into a computer to using something like machine language, it's like, oh wow, anyone can do this now. And then all of a sudden we had even C. Well, we have a compiler that will go to machine language. So we're already not actually talking directly to the computer. And then something like Java, you have like your virtual machine, which will convert it to machine code on the fly, fancy. And then Python, it's basically typing. I mean, in Scratch, you can like drag and drop things. But so we are moving ourselves further and further away from that hard computation of like, what is a CPU? What is a 1 and a 0? What is a voltage? Like, all of that has moved away from computer science. So I think it is going to get much more into the design of bigger software. So all of these steps have taken us from, like writing Pong in assembly, because that's as big as a cool program you could reasonably do by yourself, to any one of us being able to make a video game that is beautiful and you could publish and do that within 6 months. So I don't really see the idea of like AI changing that. It's just going to make us go faster and do things better, and we'll be able to do more impressive things with fewer resources.
So not just AI, maybe like every other field, how the Udemy and Coursera right now are a little bit trustworthy institutions that people study on. Sometimes people try to develop small skills from those platforms,
Oh yeah.
rather than gaining the certificates from official institutions. They try to study it from there, and they actually improve on those skills.
Oh, for sure. No, it's funny. It's one of the like developers I respect the most actually has no formal computation background. Dude works for Google now. He's one of like the 10 people that has the keys to turn off Google. So he's done.
Okay. Okay.
He's wild. I like to see this as a statistical distribution because of course I do. So imagine there's a bell curve, and there's going to be a bell curve for, I'm going to pick on technical colleges. They're great. They do amazing things. But their student base is going to be generally, fine. So their capabilities are going to be a bell curve around good. People who have signed up for the university experience are generally higher achievers. They're going to work harder. That bell curve is going to be pushed further to the right in terms of capabilities. But there is an intersection where there's going to be technical college students that are better than some of our university students, and there's going to be university students that are worse than technical college students. And that's true of Coursera too, where there's some people that just honestly just don't care to go to university, and they're going to be one of the most brilliant people on earth. So they'll easily exceed the ability of almost any university student. But how do we assess these? So this is where university starts to set on its reputation of, if we have our stamp of approval on this person, we're going to have some slight guarantee that they're maybe not garbage. They're going to be in this Gaussian curve, and we know that this Gaussian curve, by and large, is going to be good.
Okay. So only in this topic, I think we should deep dive. Like, many courses are currently online. I found that which universities, there's one university that has AI courses and machine learning courses completely online, recorded. They record their
So cool.
lectures in the classrooms and they upload it on the YouTube. I think you might know, it's one of the famous universities. They do complete recording of their lectures and they upload on the YouTube. It's for free. And there is Udemy, Coursera. They are right now not the formal education, but do you think in future they will be the formal education templates?
This actually goes to academic integrity, which is the conference I was just at, and maybe it's just the way I see the world. But it is how do we prove that somebody's actually done these? So you like sit down and you can watch these YouTube things, but you still have to be able to interact with this material, because like I was saying before, like it's theory and the implementation, and you have to be able to do both. And you could watch all the videos you want, but how can we make sure that you've picked it up? So there still has to be some way, and the way we're doing it right now is maybe not perfect, but to say that this person has put in this work. So like if it is one of these massively online courses, or MOOC, I think, how do we authenticate that this work authentically was created by this person, and then put some tooling around it? It's like, are you allowed to use ChatGPT to do this? Because first year programming, you probably shouldn't, because I actually need you to learn these fundamentals. But if you are in something else that is much bigger thinking, and you're just asking it to like make a function, it's like, I don't really know how to use sockets in Python, give me an example in this domain, and then it's just a small piece of this bigger picture, well, maybe that's fine. So it's that authentication of this person did this work, and then we can give you this human, the single human, this stamp saying, yes, you did it. If there's an online place that can do that well, they'll make all the money, and the whole university thing will potentially be kind of, what's the word, disrupted.
Yeah.
As it is, that's very hard.
Okay, but what if the certification like at the end of the exams, the exams are taken in physically, but the whole course is online? Do you think that there is potentially a threat to physical universities, that they should improve, or is there any room for improvisation for physical universities to avoid giving the same education that has already been provided online for free or sometimes very cheap?
I'm gonna say not no. The pitch for a university is that we're gonna teach. You're gonna come out as basically a flexible tool. So we make you take breadth classes. So you have to take a written course. You have to take a certain number of credit hours outside of your domain, so that you actually have these other ideas that you can start putting together. So ideally, you're doing something you're interested in. So I took film classes, and then I worked for a film studio, and that was pretty cool. And being able, like, that's the real big picture pitch for universities, right? So like you're this well-rounded academic that can attack any problem. These certifications tend to be very narrow, where it's like it's going to be machine learning, and usually very specific. It's like, I'm going to teach you scikit, or I'm going to teach you the algorithms, or I'm going to teach you one thing. So I don't see it overthrowing the university structure as a whole. But for like industry, I can see them wanting those certificates, saying it's like, well, I need a machine learning engineer. I need you to have this certificate because I want to make sure that you have at least a passing understanding of these things, so you can start working faster, harder, better on day one.
Okay, that is great. So when the students are studying in these universities, I think the one thing that makes difference is that giving the real world experience. The universities collaborate with the industries and give their students real world experience.
Yeah.
So do you have some tips for uh, the educational institutions, how to how to create these collaborations, and how do you engage with the industries to make real world connections and give real world experience to the students?
Sure. For our department, I am the Industrial and Alumni Committee Relations, whatever chair,
Yeah.
whatever our committee name is. They changed it, and I don't remember it. So I'm part of what I do at work is to try to solve this problem. So at the undergraduate level, we've solved it for about a third of our students in our co-op program. It's a very, very competitive co-op program. My understanding is, and this is hearsay, that about a half or a third of our students can get in, and the rest of them who apply just don't. And there's some people who don't even bother applying because they don't think they'll get in, which is heartbreaking, because it's an amazing program, and you get to have a year of experience along with your degree, and that sets you up really well to be very hireable when you're done your degree. So what do we do for the other half or 2/3? That's a great question. We are trying to solve it with there's an industrial project course, which if you're in co-op, you're not allowed to take. And then you get to do a project for an industry person. So you'll actually have interaction with somebody who is in industry, has a problem. And, the best possible outcome of that course is that you're hired, which has happened a few times. And I need to write them all down to put in my brag book. But that's still not quite enough. Hackathons have been a really good outlet for this, because industry can come in, pitch this weird idea, and then have people work on it, and they get to actually interact with these people. And then ideally you'll have a few different industry members in there, and they'll become familiar with you, you're familiar with them, you can start understanding their requirements, and they can see, hey, maybe these are some good candidates that we can hire, or they get an interesting problem solved from interesting people. So those collaborations are cool, but they're also problematic in you're giving it away, right? You're taking a weekend away from your life to work for free for this person. And is that fair? Well, you work for pizza usually. Is that fair? You're gaining experience, so maybe it is. I've never been a huge fan, and fun fact, I've never participated in a hackathon because I've never felt like my skills have been good enough. So I'm sure there's other people like me that I don't have the worst skills on earth, but I don't feel like that's my place. So the answer is I don't have one.
Well, you don't have an answer after this long answer, then it's really...
I'm just gonna I'm gonna just politician talk around this one. I am looking for some answers, and if anyone has ideas, I am all ears, because that's a hard one. I did put on the first alumni event at Computer Science Symposium. I invited industry members to have job booths and alumni to come into to one space, and then we had a symposium, which is a set of short talks that are all revolving around what topic, and it was amazing. We're hopefully going to do it every year, so hopefully that's going to be kind of an incubator for these ideas where we can have industry and us and students in the same room and come up with in a very informal setting, which I can totally deal with, and hopefully make some of these
Yeah.
connections.
Yeah, it's actually very delicate and a small world, like having students, alumni, professors, and the industry persons together in a single room. It's gonna be a knife fight.
It was very exciting. The first one there was no knife fights broke out, so that was okay.
Well, I think in the mindsets of people, it sure did.
Yeah. Oh, maybe.
Yeah, it's kind of very competitive. It gets very competitive, and sometimes professors might not like some things happening, or the students might
Yeah.
not like.
Oh, that's
few
interesting.
things.
Yeah. Some the what is computer science? If you want to start a knife fight, you just throw that into a room. And to the point where you arguably ask me what is computer science, and it's like, what do we do with industry versus like higher education? That's core of that is what is computer science.
Great. So talking about the industry currently, like I've heard from many of the colleagues and friends that there are hiring freezes going on in many of the companies in computer science department. They don't want to hire new people until the end of this year or the next year. And also I've heard from a few hired people, their employment the start date got delayed around 6 months or 8 months in Amazon or Google or Meta, for that fact, that people are right now the people in the industry are really afraid to hire new people. So what is your take, because this is happening as from the firing started by the top tier companies and people started coming down the hierarchy and the vacancies got occupied. What do you think, like what is beneficial for the industry, to hire the new freshers or the experienced ones? Because I think it's a story of a empty glass that you can fill it anything into a fresher, and or you get a full glass of beer or a milk.
Full glass of baggage coming.
Yeah, that also.
It's yeah, that's interesting. I've seen this cycle happen a few times already. Again, like I joined university right when the .com bubble was burst, and then it burst. Yeah, and then like these rounds of hirings and firings happen fairly regularly. It's interesting and it's hard. We are cutting edge and we cost a fortune, which is one of the reasons that it is this booming and busting thing where especially these massive companies will hire a whole bunch of people at pretty huge salaries, and then they find out, oh, we actually don't need this, and they'll cut it. So from what I've often seen is, they'll hire, I'm going to say, just for small numbers' sake, 100 people, and they'll cut 20%. But they still up 80 people. So it's not as scary as some of the statistics would lead you to believe. The hiring freeze thing is interesting. That was the first time I ever heard of it. My friend got hired at Amazon, and then they pushed back his start date, which was never heard that happen before. So I don't know if I can react to that one, unfortunately.
Yeah, they paid around 2 months of compensation salary, and but they delayed the start date from 10 months. So
okay.
I think it's not a bad thing, rather than they're not giving her the job, it's a good thing in the current world scenario. But it's the candidate might feel injustice because of this thing, because they were hoping that they could start their new life with the incoming salaries or new experience.
Especially coming out of university, people are famously wealthy, so that is hard for them to do to new graduates. I did suggest to the new graduate to just look for some freelance work, because it's actually super duper fun, and You can, sometimes there's these nice bite-sized things. You'll get paid an okay amount, and you'll learn some new skills, keep you sharp. But
Yeah,
it's those are sometimes hard to find.
yeah, definitely. Right now, in the current world, it might be hard. Mostly people are trying to start something on their own, and that is that's how they are creating opportunities in the industries. So, what do you think? Is there a scope for new computer science businesses right now? Is there any scope in the industry right now to start new, uh, invent new companies or start new ideas?
Oh, for sure. There's uh giving a I'll give a plug for Tech Thursdays every Thursday at the King's Head Pub. There's people from industry and from whatever tech stripe they've come from that go there every Thursday to talk about starting companies and getting things off the ground. And it's always very exciting. It's a very well done thing. So if you have time, look it up. If you're in Winnipeg, Thursdays, Tech Thursdays. So there's still definitely the hunger there. And there is, still cool ideas coming out, and there's going to be these disruptive ideas that will certainly take off. This is one of the good times to do it because everyone is part of the uncertainty is like, what is the next big thing? So everyone's kind of slowing down. It's like, hey, there's this AI thing. What does this mean to us? Hey, there's world events going on. What does this mean to us? And if somebody can get that idea that will unite some thing in our minds, or there's there's definitely some traction to take off. So
Okay, great. That sounds great. So, last couple of questions on this very core topic, and then we'll move to the last segment. So, what do you think? Like, have you noticed any cultural or societal shifts in perception of the people because of this computer technology, modern technology? You have been there during the dot-com bubble burst, and you are right now in the
we
chat
haven't named
GPT.
this bust yet. Yeah.
Yeah, I I think it will be named after how much long it runs. We know, like after couple of years, maybe. I don't know however long this burst is, but and there was also a shortage in between when the American market blew off, right? So, what do you think? Like, how have the societal perception changed over these times?
Well, yeah. So uh it's interesting. So like when I was first in University Center in 2003, it was like a buzz with noise. About six people in the room had cell phones, and everyone was just chatting with each other. And then you go through now and you'll see like it's actually quite a bit more quiet, and people are looking at their phones, and it's much more like this kind of um, your personal space thing. So like the idea of personal computing has definitely appeared, and that's attracted a larger breadth of people to like the computation field. So looking at what around the classroom, like when I was going through, like there was kind of like it was fairly homogenous in what you would see, where it's like largely male, not super loud. Like I was the loud person in the room, no big surprise. My best friend was the second loudest person in the room, and it was very much like there was a kind of set like stereotype. These days, that's less and less true. You're seeing much more people interested in coming in the field, and their motivations are much more diverse now. So there's like jocks in the room now, which just kind of blows my mind. Like there's people like I have students handing me these things like, oh, I play on the football team, so I'm going to be missing these classes. I'm like, you play on the football team and you're in this room? And then I have to try to not say that because I don't want to call them out on it. And it's good, right? Like we're getting more and more people interested in computing just because it has become real to everyone. So there's been huge cultural shifts from like basically nerds who were playing real-time strategy games in the 90s to people who were playing Wordle and saying, hey, this is neat.
Yeah, I think too that because I guess when I was a small kid, it was practically tough to become a sports guy as well as a nerd guy together. And right now, it seems pretty normal that people do that.
Yeah, no
And
one bad on anymore. It's so cool.
it's surprising. Yeah, it's so cool actually. I think it started in our generation from the 2010 high school students. People started to do that.
Yeah.
So I think that's the genetics power, maybe, because it's shifting. People are improving, and their mindsets are improving. They're more creative and more brilliant than the
Yeah.
from their childhood, because the
Yeah.
parents give them tools to do everything. Maybe that is the key.
Yeah.
They become multitaskers. So, uh, in your opinion, what should be the ultimate goal of computer science education, and how can we ensure that it remains relevant and impactful for the future upcoming generations in with the perspective of new language models coming up?
Yeah. So I have to take it from like a higher learning perspective. So like skills are very important, obviously, but it comes down to the people. I mean, I'm very people oriented. You may or may not be surprised, but it is about the people, because like we have to try to get through to more diverse people. Like our classrooms are getting more diverse, but it should be much more diverse. So we have all these voices that actually, represents the population as a whole, that are feeding into the system, especially with the idea of AI and like a computer learning. There is biases that we write into our code, which is terrible, and it's actually really hard to escape. Even Zoom, I'm looking at right now. It does kind of like noise and voice tracking, and it'll turn on your microphone if you're talking. Otherwise, it'll mute you. Or even like the volume levels will jump, and it does cool stuff. And it was clearly trained on a male voice, especially like a loud male voice. And if there was two people in a microphone, it would almost always ignore the woman like that was also trying to speak. And I was like, wow, this is actual like digital sexism. Like, this is crazy. And we need to be able to talk to these people as people, and like you are building something that does affect other people's lives. So the idea of ethics is going to be built in more, and the idea of like who you are is going to be slightly more than what you know, I think. Like, and be able to see these bigger systems, and again, make these connections from computation to whatever you're solving. And that's true of if you're building like an app that does something versus AI that is going to be that middle layer that will still do something. So yeah, I think it's going to be much more important about who is there and getting those ethics into them.
Great. So finally, we'll move to the final segment of the show. So this segment is particularly I've designed for the current most debatable or controversial topics to know your perspective, as well as to maybe mold the perspective of people, because many people start believing wrong things what they see on the Instagram, and I think if they hear it from the professional, they will know that some things are falsely accused of. So first question is going to be like, how do you navigate the ongoing debates surrounding the standardized testing, curriculum standardization, and the balance between the individualized learning and the standardized benchmarks that were established?
Oof. I see that as you have to look at as this is a pedagogical thing. So like if you are these benchmarks have been created for some reason, like, so we have to take that a step back and say, is it actually accomplishing what it's supposed to do? So getting a university degree is a certain benchmark, and ideally, people who have been issued that have earned that. So are we doing a good job of it? There's a big hot open debate there. Are we open to try to improve? I hope so. So I think all of us have to take that step back and say, like, is this testing doing the thing that we were hoping it's going to do? And this actually does even go into the ethics of are these tests actually holding people out that maybe should be here, whether that be intentional or accidental.
Okay. So, do you think that integration of AI and virtual reality can be useful? I mean, Meta is creating really good metaverse. Actually, the research I've heard from couple of insiders that their metaverse is really good at establishing your physical body into their virtual, and then when you connect to the other people, it really feels like that you are actually touching them. So, do you think that this metaverse can be integrated in the education system to make it more powerful or make it more useful? Like students sitting in the classroom, maybe they can raise their hand up in the class, sitting from their home. So
Yeah. So in terms of a classroom, I had to disagree. Like learning at like there's what are the outcomes of university? And it's not just the ability to write a test, or shouldn't be. That's unfortunately the only thing we assess, which is a problem. But we do want to put out like fully formed human beings that can interact with other fully formed human beings. So being in class is something that's really, really important. And like talking to your peers, learning from your peers. Can virtual reality do some of that for us? For sure. This goes into your last question of like, do you start creating an echo chamber? Because universities are places where it's supposed to be safe to have any idea. And to a point where like there's a fault where, you have to put up signs saying, watch out, there's pictures ahead that are like nasty and you maybe don't want to see them and you maybe don't want to hear the message that they're putting out. But that is something that we need to welcome in a place of open learning. And if you're not getting exposed to that, you will create these echo chambers of like, well, this is the way we all agreed. Me and all 5 of my friends think exactly this way. It's got to be that way. And hearing somebody else's opinion is hugely valuable. Again, we don't assess you on that, but it's something that we hopefully create an open space for.
okay.
So anyway, virtuality, yes, I think there is some space for it to grow in the classroom. But there's some things that we shouldn't replace too.
Yeah, the real touch.
Yeah.
So the internal student of me, inside me craves that I wish we had the VR system, and in some way that everybody in any corner of the world would study in the same university, are able to study in the same university as well as feel that they are in the real live classroom. I guess
Cool.
that is not the VR system. The advanced VR system would not allow people to cheat because they would detect their body movements. So I don't think that
Yeah.
ethical debates would be there around.
Yeah, hopefully not. Yeah,
for that.
ideally we'd solve that part.
Yeah.
But would you feed that into Coursera? Like, can we create something bigger that is international? Like, that'd be cool.
Yeah, that would be really cool.
But
But
who else
also
have
I
the
think,
community is my question.
yeah, also I think, but the neutral perspective says that to save the human race from abomination of our our race, I think we should avoid doing that.
Yeah. Oh man, that's interesting. Yeah, like
Coming the chat GPT, I mean, there have been real talks. I think robots will create themselves their own robots, and they don't have to destroy human lives. They just have to create new robots to avoid humans from doing the real work.
Right. You give it the parameters of you need to solve this global climate crisis, and it's gonna be like, well, humans are doing this, so you came to the right conclusion, but please solve that in a nice way.
Yeah, I mean, it's scary. It's scary if we thought that if we think for the next generation. I feel that's really scary. But at the same time, I think it can be useful as well. Maybe it's not that so bad. Humans will find a way to coexist with the future technology.
Yeah. Yeah. And it's funny, like technology does have the ability to bring us together. And uh, if somebody could figure out a good way of doing that, man, it could be something for sure.
So, do you believe in matrix or like that kind of stuff?
Oh,
That we are the small,
the major.
we are very small, we are small elements of the bigger universe, maybe.
It's funny. I've had many conversations of like, are we living in a simulation? Because that's always a hot question of like, well, how do we prove it doesn't exist? Well, you can't prove something doesn't exist because that's not how proofs work. So, I don't think so, but I also will never say no to it.
It's a very thin rope to
Yeah.
walk on. So the final question: are there any specific topics or trends in computer science that you should pursue? I've heard that many people who have done PhDs also get fired, and many people who haven't done any formal education, like your friend, is still in the Google and holds the most important position. So, what are the topics that you pursue? I mean, that should be important, because I think sometimes people do get a good education, they are expert in their system, but that technology is not useful further to the industries.
Yeah. Well, I've always tried to like make myself as like almost random, but as general as possible. So, um, and that's something that I've always just been. I'm interested in too many things, so I've never had the problem of being overly specialized that I've become not useful. And I don't know if that's very good general advice of like never specialize, because I think that's not for everyone. But for what I've gone through and what I've done, it's been a very good choice that I've made. Like even going through my degree, there's streams, I forget what they were called, and I looked at them and said, well, that's interesting, but I'm going to take these random courses because that's what I'm interested in. And that worked out for me because my jobs were random stuff that I was interested in. So um, I think you just have to kind of follow your own path and be passionate about it. And if somebody sees that you're passionate about stuff and you're actually good at like general things, I don't think that layoffs would be, in your future. It'd be they'd find something else for you if you're a good fit in the company. So I guess it goes back to being a fully fledged human being, and like you're well-rounded, you have these other experiences, you can make these connections and have more than just one skill that you have to offer.
Yeah, definitely. So this ends the main conversation. Thank you very much for your time, Professor.
It was fun.
So thank you guys for watching the entire video. If you did like the content, please hit the like button and comment with whatever feedback you have and what you want to see next. Also, if you like the video, please share it with your friends, upcoming students, and the parents who are sending their kids to the Canadian institutions for their forward education. If you have not yet subscribed to this channel, go below, hit the button subscribe, and also hit the bell button to stay up to date with the new videos. I hope you guys like the content and this helps with the new generation. Thank you very much.